forget self-driving cars and computers that can beat humans at chess. Artificial intelligence is helping astronomers make huge steps towards solving some of the universe's biggest mysteries. For the first time, artificial intelligence has been used to discover 2 new exoplanets. One of the discoveries, made by NASA's Kepler mission, brings the Kepler-90 solar system to a total of 8 planets, the first solar system found with the same number as our own. The majority of exoplanets are discovered using what is called the transit method. Telescopes are pointed at stars, studying them over long periods of time, which means they can look out for tiny dips in the brightness as a planet passes in front. Instead of looking at pictures, the presence of planets tends to be discovered by studying the large amounts of data taken from the telescope, related to the brightness of an image. When a solar system has more than one planet, the dips in brightness occur in complicated patterns, from which the planets' masses and distance from their star can be worked out. At the moment, the dips in brightness are spotted using automated computer tasks, and sometimes just the human eye. Like most tasks involving complicated data, machine learning has proved to be helpful in deciphering these patterns. In the latest discovery, researchers trained computers to sift through the data and spot tiny dips in brightness that had previously been unnoticed. Christopher Shorlew, a senior software engineer with Google's research team Google AI, and Andrew Vanderberg, astronomer at the University of Texas, Austin, trained a computer to learn how to identify exoplanets in the light readings recorded by Kepler. They used 15,000 signals to train the machines using a neural network, which mimics the way the brain works. In my spare time, I started Googling for finding exoplanets with large datasets and found out about the Kepler mission and the huge dataset available, says Shorlew. Machine learning really shines in situations where there is so much data that humans can't search it for themselves. There are 35,000 possible planetary signals in the data Kepler gathered over its 4-year period of operation. The neural network Shorlew came up with can identify planets with a 96% accuracy. Although it does find some false positives, within those it picks out there are lots of potentially real planets, like the 8-member of Kepler-90I, which lies 2,545 light-years from Earth. The second exoplanet confirmed to be found with this method is a 6th planet in the Kepler-80 system. Just as we expected, there are exciting discoveries lurking in our archived Kepler data, waiting for the right tool or technology to unearth them, said Paul Hertz, director of NASA's Astrophysics Division. This finding shows that our data will be a treasure trove available to innovative researchers for years to come. Beyond exoplanets. Finding exoplanets is by no means the only astronomy task machine learning is helping out with. In fact, most of the biggest questions in astronomy right now are being tackled with the help of AI. Take the search for Planet 9, a mysterious planet predicted to lie on the outermost part of our own solar system. While the presence of the planet has not been confirmed yet, the observations that led to the prediction have not been adequately explained by any other theories. Machine learning could definitely help the search for Planet 9, and likely already is, says Vanderberg. One of the biggest breakthroughs in machine learning for astronomy was the ability to spot objects that suddenly appear or disappear, in large sets of observational data. In a paper in 2015, a group of astronomers made the first steps towards using AI for this purpose. This kind of AI could be useful for finding Planet 9, or other new objects. Gravitational waves. AI is also being developed to help detect gravitational waves. The announcement of the first gravitational wave discovery in 2016 and the more recent detection of a neutron star merger are said to have opened up a new era in astrophysics known as multi-messenger astrophysics, studying events using not just light. In a paper last month, 2 members of the LIGO collaboration showed how a kind of AI called deep filtering could be used to sift through the data collected by the detectors to spot gravitational waves. we demonstrate for the first time that machine learning can detect and estimate the true parameters of real events observed by LIGO, the paper says. Dark matter. As if a Planet 9, exoplanets and gravitational waves were not enough, AI might also help in the quest to find dark matter. This week, a paper was uploaded to the ArXIF server that described how machine learning could help us to identify a weakly interacting massive particle, a kind of particle thought to be one of the possible dark matter candidates. We show that if we discovered new particles at CERN's LHC, we could prove they are the dark matter in the universe, thanks to complementary data from astroparticle experiments and the use of machine learning tools, says Gianfranco Bertone, astroparticle physicist at the University of Amsterdam and co-author of the paper. In these kind of direct detection experiments, machine learning is useful to speed up the process of removing interference produced during the complicated and high-energy processes involved. Machine learning was central to making this study possible. Without these tools accelerating the inference, the computational cost would be prohibitive, says Sebastian Lam, another co-author. There is a lot of hype about artificial intelligence. Whether it could bring us self-driving cars, machines that swear at you, or possibly even a new form of human that could replace our own. The possibilities of a future with AI are difficult to guess, and often quite daunting. One thing we know for sure is now, in the field of astronomy, AI is making huge discoveries possible. Thanks to new techniques being developed right now, it's likely it will continue to do so in the future.